Hi everyone, this is part 3, and in part 1 and part 2 I have covered two questions of a graph so that you can understand what is graph. Now this video is totally dedicated to the proper dry run of a code because I consider that the one thing that is important in graph is dry running the code and understanding how the code works, and with the help of any input you have to check your code and how the codes work, right? So like in the second video, this was the code, right? And this was the example. When I was manually checking the path, I actually checked for three paths. I actually write the three paths, but there is one more path. So with the help of this dry run, I will not manually writing it. With the help of this dry run, we will be able to get all the possible paths. So I am again dry running it so that you can able to found all the path and how the code is working, right? So now I will again write the input, given input as a graph. So this is zeroth index, sorry, zero vertex is first, second, third, fourth, fifth, sixth. Initially they all are marked as false. So I will say false, 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 and false. Right? Now we will do a dry run with the help of this code, right? So we will start with 0 and we need to reach at the 6th. This is the destination. Node 6 is the destination. So source is 0 and destination is 6. So destination. Now we will start with 0, right? So zeros, so we came at this point. 0 is not equal to 6. So we will come to this point. We will mark 0 as true. So we will mark 0 as true. Now we came into the neighbor of 0. So zeros neighbor are 1 and 3, right? Now we we do a recursive call because since neighbor of 0 is 1 and it is false, so that's why we will do a recursive call again in 1. So recursive call, so how many neighbors of 0 are there? 0, and then neighbors of 1 is 0 and 2. So this is 2, right? Now we are at 0, right? Since 0 is already marked as true, so we will not check for 0. We will not check for 0. Now we came into second neighbor of 1, that is 2. So we are at this point. 2 is not equal to 6. So this will not run. This before that, like we already came forward from 1, so we will mark 1 as true. Now we are at 2. 2 is not equal to 6. Now first of all we will mark 2 as true. Now we will check 2's neighbor. 2's neighbors are 1 and 3. So 1 and 3, right? Now 2's neighbors are 1 and 3, so we will start with 1, right? 1 is not false, so we will not go in this path. Now we came into second neighbor, that is 3. So 3 is false, so we will do a recursive call making 3 as source node. So we came into at starting. So 3's neighbors are 0, 2 and 4, right? Now we mark 3 as true, and then we will check in the neighbors. So 3 neighbor 0, but 0 is marked as true, so we will not do anything with this. 2 is also true, so this will also not go into this path. Now check with the 4. 4 is false, so 4 is false. We do a recursive call from 4, and so we are at this point. Then we will check 4 is not equal to 6. so this will not run. Now we will mark 4 as true. Now we will check its neighbors. So 4 neighbor are 3, then 5, and then 6, right? 3, now we start with 3. 3 is not false, so that's why the recursive call will not go into this path, so this will not run. Now checking with 5. 5 is marked as false, so we will do a recursive call from 5, making 5 as a source node. 5 is not equal to 6, so this will not run. Now visited of 5 we will mark as true. Now we will go into its neighbor. 5's neighbor are 4 and 6. Now we will check with 4. 4 is already marked as true, so this will not run. Now we came into 6. 6 is false, so we will do a recursive call making 6 as a source node. So we are at this point. Now check, source is 6, destination is 6, so we will return from this point. So from this point, which path we have followed? This, 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 and this. So this is our path 1. So 0, 1, 2, 3, 4, 5, and 6. 0, 1, 2, 3, 4, 5, 6. So this is path 1. Now since we are done with all the neighbors, like we are returning, we returned from 0 to 5. Now we are at 5 and we are at this line of 5. Now we are done with all the neighbors of 5, so we will return back from 5. We came to point 4, sorry, node 4. Now at 4 we are at what position? We are inside this, and we are done with its 2 neighbor. Now it's time to go with its another neighbor, but before that we need to check if 6 is false or true. 6 is false, so that's why we will make a call making 6 as a source node. Now the second path is like this. Now we are at this position, 6 is equal to 6, so we will return from this only, right? So we again got another path, that is 0, 1, 2, 3, 4, 6. So 0, 1, 2, 3, 4, and 6. So we got path 1 was 0, 1, 2, 3, 4, 5, 6. Path 2 is 0, 1, 2, 3, 4, 6. So now we are done with all the neighbors of 4, so we will return back from 4 to 3. Now we are at 3, we are done with this, and okay, there is one thing that I was missing in this, that is visited of src. We have to mark it as false, right? So like when we are returning from 5 to 4, we have to mark it as false. So again we need to mark it as false, and when we are moving from 4 to 6, 4 to 3, then also we need to mark it as false. Now we are at 3, right? We are done with all the neighbors of 3. Now we went back to 2, but before that we have to mark 3 as false again, right? Now we came to 2, we are done with all the neighbors of 2, so we have to mark this as false, so 2 also false, right? Now again we came to 1, right? We came to 1 and we are done with all the neighbors. Now we came to this point and we have to mark 1 as false again, right? Now from 1 we came to this point 0, so we are done with its one neighbor, I mean it has two neighbor, we are done with its first neighbor. Now it's time to check, go into the second neighbor, but before that we have to make sure that it should be false. Now check 3, 3 was false, right? So we can do a recursive call from 3, right? So we will do a recursive call from 3, so we are at this point right now. Now we will check 3 is not equal to 6, so this will not run. Now visited of 3 we have to mark is as again as true, right? So 3 become true again. Now we will check its neighbor. Three neighbors are 0, 1 and 2, right? See, 0 is true, so we will not do a recursive call from 0, right? Now, sorry, this is 2 and this is 4. Three neighbors are 0, 2 and 4. Now we will check with its second neighbor, that is 2, and 2 is false, so we will do a recursive call from 2, right? So now we are at this point. We will check 2 is not equal to 6, so this will not run. Now we have to mark 2 as true, so we again mark 2 as true, right? Now we are into the neighbors of 2, so 2's neighbors are 1 and 1 and 3. 1 is marked, 1 is like we have to do a recursive call, but first of all we need to check 1 is the neighbor of 2 and it is false, marked as false, so we will do a recursive call from 1 to its neighbor. We are at this point. Since we have to do a recursive call, so 1 is not equal to 6, so this will not do anything. 1 become true again. Now we will check into one's neighbor. One's neighbor are 0 and 2, right? See, 0 is already true, so this will not work. One's neighbor is 2, 2 is already true, so this will not go further. Now we came to 2 and we need to check its second neighbor. Second neighbor is, before that, like when we are moving from, when we are done with all the neighbors of 1, then we need to, like we are at 1 and we are done with all the neighbors of 1, so when we are done with all the neighbors of 1, then we need to mark 1 again as false, so we will mark 1 as false again, right? Then we will go back to the 2. Right now we are at 2 and we are at its second neighbor. So 2's second neighbor is 3. 3 is already true, so we will not do anything further. Now we have to return from 2, like we are done with all the neighbors of 2. Now this will execute, so 2 again become false, right? Now we are done with all the neighbors, so we will go backtrack to 3. Now 3 is 2, 3 has 3 neighbors, so we are done with this, and now remaining is 4. Now we are at 4, right? 4 is not equal to 6, so this will not run. Now we have to mark 4 as true, so we will mark 4 as true, right? Now 4's neighbors are 5 and 6, right? Now we are at this position of for source node as 4. Now 4's neighbors are 5 and 6. Now we have to check if 5 is true or false. So 5 is false, so we will do a recursive call making 5 as a source node. So we are at this position. Now 5's neighbors are 4 and 6. So 4 is already, now we are in the 5. 5 is not equal to 6. We have to mark 5 as true. Yeah, we have to mark 5 as true. Then we will go back, sorry, we will check its neighbor. So 5's neighbors are 4. Now 4 is already true, so this will not work, this will not go further. 5's second neighbor is 6. 6 is marked as false, so we will do a recursive call in making 6 as a source node, right? So we are at 6. 6 is equal to 6, so again we got our third path, that is 0, 3, 4, 5 and 6. So 0, 3, 4, 5, 6. So the third path is 0, 3, 4, 5, 6. Now since we will return back from this point to this, now we are done with all the neighbors of 5, so we have to mark 5 as false again. So false. Now we will backtrack to 4. Now we are done with the first neighbor of 4. Now we will go into second neighbor of 4, that is 6. and 6 is marked as false. So we will at this position now 6 is equal to 6. Again we got another path, that is 0 3 4 6. So the fourth path is 0 3 4 6. So the fourth path is this, right? Now we are done with 6. We came to this point 4 4. We are done with this this also. All the neighbors are covered. Now we have to mark 4 as false again. So we will mark 4 as false again, right? Now we move backward to 3. Now 3 is all the neighbors are done, so we will mark 3 as false again, right? Now we are done with 3. Now we backtrack to 0. 0, so all the neighbors are done, so we will mark 0 as false again. So yeah, this is actually our dry run. And you see that when I was manually writing the all the possible path, I missed the one, but when I dry run this, I got all the 4 paths. And I hope that you also able to follow with me when I was try running this code. I hope you will try with your own self, because this is the actually example that actually makes you how to dry run it, because it has a depth understanding of the graph, and you will also able to dry run it properly. So that's all for this video. Thank you.